Let's work a physics problem. Chris carries a carton of milk, weight of 10 newtons, along a level hall to the kitchen, a distance of 3.5 meters. How much work does Chris do? Okay, now this is a little bit of a trick question. Okay, so let's do given, find, and solve. Given. Okay, so here's the hallway. We're going to have a displacement of 3.5 meters. That's delta x. And we don't have to draw Chris. Well, we can draw Chris, okay? But here's the carton of milk. So here's our little carton of milk. And Chris is holding this carton of milk. Let's go ahead and draw Chris. And he's kind of holding on to this milk right here. And he's going to walk this 3.5 meters to the kitchen. Now this milk weighs 10 newtons. So we'll put like this: force of gravity is equal to 10 newtons. And what we want to know, and this is, let's give Chris a hat. Okay, this is Chris. Good old Chris. All right, now find the work done by Chris. Okay, so let's solve it. Okay, well, the work done by a force is equal to that force times the work's displacement times the cosine of the angle between the force and the displacement. Now let's take a look at the force that Chris applies to this carton of milk. Let me redraw the milk, make it a little bit bigger. So here's my carton of milk. Okay. And now what force is he going? Now let's just assume he's going to walk at a steady velocity across here. So look, here's gravity. Thank you. Here's gravity pulling pulling it down. Now what does he have to do? He has to apply a normal force, or we could call it an applied force. He has to hold the milk up. So he's grabbing it on the side here. So this is the force of Chris, F sub c, force of Chris. Now, this milk carton is actually probably moving to the right a little bit. I mean, it's moving to the right with a very small velocity. So at some point, Chris had to give it a little horizontal shove to get it up to speed. But that's a very tiny force. It's not going very fast. And then when he gets to the kitchen, he's going to stop anyway. So while he's walking across this, and this is the thing that's hard for students to understand. It's a little bit, it is difficult. Chris is really just picking the milk up, even though the milk is moving to the right. So we know that the force of Chris has to equal, has to be equal and opposite to the weight. The weight is 10 newtons, right? So Chris has to pick up the milk with 10 newtons of force. But the displacement is like this. Here's delta x equals 3.5 newtons. And so when I'm going to look at this situation, I say, well, the force vector that Chris is applying is 10 newtons up. And the displacement has a magnitude of 3.5 newtons. But what is the angle between the force that Chris applies to the milk and the displacement vector? Well, that's a 90-degree angle. So this is going to be the cosine of 90 degrees. And what is the cosine of 90 degrees? 0. So the work done by Chris is 0 joules. No work is done. And so it's a little bit counterintuitive. If the milk started from rest, you would have to give a little bit horizontal shove to it. That would give the milk a little bit of kinetic energy. But really in this problem, once you get going, if you're looking at the problem just while he's transporting the milk across, he's not doing any work. Yes?
Is it 3.5 meters?
Oh, 3.5 meters. Thank you. Gee whiz. I was just testing you, see if you're paying attention. The question was, should this be 3.5 meters? Yes, it should be 3.5 meters. So, you know, well done, Daniel. You're part of. Justin, you took credit for. That's okay. That's the American way. All right. All right. That is all.